Hello, everyone.
Hello, Dr. Shahir.
Hello.
Bonjour.
Bonjour. So we will continue the model that we started on Monday. So I remind you that the second model that we have seen is the model that includes a second sector. This model, I mean, the main difference between this model and the other one is that we introduced the set command. So once we finalize this model, we'll be working on introducing the government and the rest of the world. And then I will show you a very short introduction to the dynamics, to the dynamic models. And then I conclude today's session with a real model calibrated on the Egyptian economy. And we'll share with you also some papers on that and some resources at the end of today's course. So any question before we start?
Professor, by dynamic modeling, we mean we are going to introduce the time dimension?
Yes.
Okay, thank you.
Other questions, requests? Okay. So perhaps, so we'll do like what we did on Monday. We need someone who shares his or her screen so that we can correct the model together. So anyone who wants to
Est-ce que
start?
je partage l'écran?
Oui, s'il vous plaît.
D'accord.
So Hajar will share her screen, and perhaps who wants to comment on Hajar's code? Fuad, would you like to do it? Fuad.
Yes.
Okay. Would you like to comment on Hajar's code? We can't hear you.
I am looking for some errors.
Okay, so Hajar, would you please go, scroll up to the beginning of the code? We can, no, the beginning, le début du code. Yes.
D'accord.
Okay. So Fuad, if you don't find errors in this part, please tell her to scroll down. And if anyone also has any comment before we scroll down, please go ahead. So
Okay,
shall we scroll down? Okay.
Yeah.
Continue, please, Hajar. Why, Mehmet, you can't see anything? I mean, can you see? Oh, okay.
There is maybe G demand in function of E.
Exactly. So, Hajar, do you see that the G demand? It's missing an I. G demand in the equation. No.
D'accord.
Yes. In this part, you have the G demand. G demand.
D'accord.
G demand. Yes. You have to add the I because this function is indexed on I.
And also for the supply, I think.
And you need to add it in the equation also.
Sorry for it.
I told her to add it in the equation of the...
Exactly. And supply, as Shaima is saying, so for the supply equation, there is a missing I.
Supply.
In the beginning, exactly.
Yeah.
Okay. For the equations, I think it's fine now. Let's check the calibration. Scroll down, please. RPW, labor capital. So again, you have to remove the LO and KO.
Yeah.
What else? You have to remove them. Non, il faut effacer KO et LO égale 4 et égale 6.
Ah, d'accord.
Avec le point virgule, voilà. What else? Add anything that's missing here in the calibration part?
Professor, I think she didn't respect the order of the functions of calibrations, because as we said, the order is really important.
Yes.
Exactly. And what's the problem here with the order?
So the LSO sum and the KSO sum, they need to be before the
Declared.
O.
You see?
No, not
Yes.
necessarily. Not necessarily, actually.
D'accord.
Because she's using LSO and KSO to calibrate the income.
Okay.
So no need to have them before. But there is another error here in the calibration.
For the brackets or for the order of the equations or in calibration?
There is an error.
This is
You
a-
have to detect it.
Missing in beta I, missing bracket in beta I.
No.
I
No,
think the
nothing
Y should
missing
come
there.
after the income.
Sorry?
The Y should come after the income.
Which
Or
Y?
not YO, or not necessarily.
No. Especially for Y, it has to be here because the Y is used
Defined by KO
in
and
A.
LO. Okay.
Y is used in A, and that's why we cannot calibrate the A without calibrating the Y.
Okay.
The function of AI needs to be at the bottom of the calibration part.
The alpha.
No, not necessarily, because we have the alpha before.
Okay.
No, but there is an error here in the alpha.
Alpha should come at the end, no?
No, it can't, because we'll be using the alpha to calibrate the A.
To calibrate the A.
No, what's missing here in alpha?
I don't see. I don't see.
No, I mean, for the brackets, no, the brackets are correct, but something very important.
The order?
No.
Exponential?
No.
I don't see anything missing.
No, there is something that is so for the alpha, okay, Li 1 minus alpha, K alpha. Okay, so let's run Hajar. Please remove the shock first. Remove this 1.2. No, at the end. The initialization is fine. Any comment on the initialization?
Just a second, I have to check. The initialization of LS. I think it's missing.
SC?
No, it's here. LS, you say?
Yes, the supply. Yeah.
But without a shock, you have to remove
We have
the
just to remove the
1.2.
shock. Yes, we have to remove the 1.2. Yes, remove this Hajar. Il faut effacer le fois 1,2.
And P is
And
and P isn't endogenous, right? Should be FX.
no, because
No,
actually,
the one of agriculture, the one before.
yes, but this one is correct because here we're saying that all prices are endogenous, but the only price that is exogenous
agriculture.
Exogenous agriculture.
Okay.
So please run Hajar. Lancez le modèle, s'il vous plaît. Ah, vous avez un problème de licence.
Ah, d'accord, oui.
Donc, il faut chercher la licence depuis votre email, parce que la licence est envoyée par mail, et puis la sauvegarder sur votre ordinateur, gamslist.txt, et puis importer cette licence dans votre code.
D'accord, OK.
Bon, we can post to another code. Who wants to share his or her code?
Dr. Shahir, can I share?
Okay, Passant, go ahead. And then Muhammad, who will share after her. Okay, so I mean, it's a very cosmetic and minor thing, but it's very important, Passant, to make your code aligned, because the more the code will be, I mean, you will have more lines, the more it will be difficult to follow. But this you can do later.
Okay.
Let's continue.
Okay.
So the first thing, we have to remove the spaces between the index and the letter.
We have to welcome our new member, I guess, Dr. Mahmoud Khairi, or Khairi.
Sorry, Aziz?
I said we have to welcome our new member, Mr. Mahmoud Khairi, or Khairi.
But Mahmoud, no, Mahmoud was with us from the beginning.
I didn't notice that. Okay.
Mahmoud Abdel Qadir, right?
No, I mean Mahmoud Khairi.
Yeah, but I think he's the same person.
Okay. My bad.
Okay. Beta I. You have just a second. Income, consumption, YKOLO. Okay, go ahead. Supply, demand, G demand. Okay. Supply, Y, A, K, I, alpha, L1, L. Sorry?
J'ai demande équilibré par Sam, non?
No.
Yeah, exactly. We have to remove the sum. Exactly.
Yeah, we have to remove.
G demand percent, you have to remove the sum that you have. Exactly.
Oui.
You have to remove it with the index and with the bracket.
Here?
Yes.
Yes.
The last bracket as well. So PI, RK, income. Okay. Go ahead. RPI. Okay. Then we calculate the volumes, value added, labor supply, capital supply, income. Y. No, Y here, we cannot include it once again, so we have to remove it.
Yes.
No, the next one. Exactly this one, remove it.
I remove this one? Okay.
Yes, all the line.
Because it's already declared, so.
Exactly. Okay. Then consumption, it's correct. Alpha. What's the problem here?
I should add the RO.
RO?
Exactly. RO multiplied by KON. You have to add a bracket before and after.
Multiplied by KOI.
Yes.
And
Divide
prices multiplied by y.
And here,
Add a bracket, POI multiplied by y.
PO.
multiplied by POI.
Right.
Yes. And
Yes.
then close the bracket, exactly. And then for the AI also, it's not correctly calibrated because you're writing here KO to the power alpha divided by LO. It's multiplied.
Should be multiplied.
I should add brackets or no? No.
No. Beta. Okay, it's fine. Scroll down. Initialization. So what's missing here in the initialization? Aziz, what do you think?
The income.
P.
No, not income. Income is
The,
here.
the P, the endogenous P.
Prices, exactly.
The prices. Yeah.
So you have to declare that all prices are endogenous, and among these prices, one price is exogenous. So P dot Li equal POI.
And the price of agriculture is already declared. So
exactly. Semicolon. Exactly. Run the model, please. Okay, great. So we have two syntax errors here. Click on the first one. So here it's telling you that there is a bracket missing.
Okay.
So click on the line and then go to the code in order to see exactly. So maximize this. And we have to check which bracket is missing. So we have a bracket KO alpha to the power alpha multiplied by LO1 minus alpha. We close the bracket of the I of the one. Yes, there is a bracket missing after, at the end. No, at the end.
At the end?
Exactly.
Yes.
At the end. At the very end. Yes, exactly.
Okay.
Run once again.
Okay.
So you can see here, we have the invisibility is of 8.8 multiplied by 10 to the power negative 16, which is fine because it's 0 in the pre-triangular and the post-triangular. And then let's go percent to the listing code. Maximize, please. Yes, maximize, exactly.
Okay.
And then up there, write in fez in order to search to make sure that we don't have any invisibility. Up there in the small window beside this ALA, exactly. Write in fez. No, INFES, exactly. And enter.
Not found.
Not found. Great. So please stay on this listing file. Go towards the end.
The end.
So if you remember, we have the code, we have the system. Scroll down, please. The calibration. Scroll down. Again.
At the end, we're going to have our solutions.
Yes. Scroll down again, percent.
Okay.
Here we have the solution. As you can see, all the left-hand side are equal to 0, which shows that we don't have any invisibility. Scroll down again.
Professor, and what does LHS stand for?
Left-hand side.
Ah, I see.
Down, please. And as if you remember, for everything, all variables that are numbers, their upper and lower limit are negative infinity to minus infinity. So that's why we have negative inf and plus inf.
Okay.
Again, stop here, please. Just a second. I'll bring the charger. Just a second.
Okay.
So as you can see at the end of this, please move upward. Yes, here. So if you can see, we have here 13 single equations. We have 16 single variables, and that's why we have our 3 exogenous variables and 13 single unfixed variables. Okay. So that's the model that works, but without a shock. So before running the shock, so Passan, please stop sharing your screen.
Okay.
Thank you. We can now move to the last model that we'll see today, the model of Mehmet. So please share your screen. And
can you see it now?
Jala, would you please, sorry?
Can you see my screen now?
Yes, we can.
Yes.
Okay.
Yes.
Jala, would you please check the the codes of Mehmet?
Sure. Just a second. I think the variables are okay.
There is a
please.
there is a missing point comma at the set.
After set, right?
After set, you have
After
to.
set and
Yes.
before
Yes.
variables. Then parameters AI, alpha I, inc O. I think for the parameters we're good.
Yes.
Then for the equations, just a second. For the equations for their names we're good. Then for the equations themselves. I think we're good also for the equations.
Okay.
themselves.
I think subscript I missing in the supply should be YI, and in labor it should be LI, or
Yes.
You mean here?
Yeah.
Yeah.
Everywhere. In the Y, in the K, and the L.
Yes. Yes.
Scroll down, please. Now we're in the calibration.
RO1, POI. I think, no, wait, don't. I think we're good with the calibration.
Okay, and the order is
sorry,
fine.
I think, I'm sorry, but in the income it should be multiplied by R, not plus R.
Yes.
Oh, right. Multiply WO multiplied by LSO plus KSO. Okay.
Initialization. So for the initialization.
Yeah, I'm checking.
Yeah, there is problem with I. I think index after the N with Y.
Which one?
The third one. And
You have to have the bracket I after the L, not before the L.
yeah.
Exactly.
For
And
all.
with the K and L, the same.
And W and R, they don't.
Exactly.
They
So W and
shouldn't
R, they don't have an index I.
Yes.
What else here?
Is there a problem about the order of the price?
Exactly. So the order
Price,
of the
the
price has to
exogenous.
be declared first as an endogenous variable, and then we fix one of them. Exactly.
Okay.
Run, please.
Text and on text.
No, but please deactivate, Mehmet, please deactivate the part before, yes, before the parameters.
On text and off text.
Exactly.
Dollar.
And at the end of text.
So now try to run again. Good.
So please open this part. Great. So we have the same thing, no infeasibility, feasible solution to a square system. So any questions on this code before we continue? Okay. As per, please stop sharing your screen, Muhammad. So the last thing I want to show you is how we change the extraction table. Okay, because now for the extraction table that we have, we must include so we must include the sector dimension, right? And until now, in the old table that we had, we didn't include this sectoral dimension. So what I will show you, will not do it because it will take some time, and I want to move to the second model, to the third model, sorry, to do the simulation first and then to move to the third model. So I will show you how the new table is coded. Okay. I will share my screen now. So you will see that the code is identical to what you have, but the only difference is that, as you can see, at the end of this table, we have a new command that is called loop. And this command loop means that we want to make GUMS do a loop over the same command. We can use it for equations, we can use it to extract results, we can use it for anything. And that's why now we will have, if you remember in the previous code, we had just 4 columns. Now we have 5 columns. And these 5 columns, one of them will include the sectors, as you can see, okay? And as you can see as well, we have to do 2 things. So first we have to have for the parameters that we declare with the same index I, for the formulas that we have to include the i's as well. And for the table, we must include a column, the second one that we have here for the sector. And for the sector, we add I.tl. This .tl will mean for GUMS that this variable will have to be measured once for agriculture and once for industry, okay? And that's why we'll have the base for agriculture and the base for industry, okay? So once we run this, we will get a table that includes the results of the simulation. So given the fact that the last simulation was an increase in capital supply, now we will have another simulation where we will increase labor supply, okay? I will increase labor supply by 20%. So I will run this simulation and see what we have. You can see my screen, right? Okay.
Yes.
So as you can
we just see the gums. We can't see anything else.
yeah, I mean the gums code.
The gums code. Yes.
Yeah. So here, as you can see, we have an invisibility, and as I said, it makes sense because now we have a simulation. So my variables of the base here are shocked, but then GUMS will run several iterations in order to find a new equilibrium. And the equilibrium that it reaches after 12 iterations has an invisibility of 5.59 multiplied by 10 to the power minus 10, which is very good because this means that we have a new equilibrium with no invisibility. And then I'm told that we have a feasible solution to a square system. And we will see that we have here at the end, the Excel sheet where I have my results. But before going to the Excel sheet where I have my results, I want to make sure that the invisibility I have is only in the equations where I have explicitly the LS variable, which will be which equations?
The
where we have explicitly labor supply,
the revenue, and the equation of labor supply itself, which is the sum of Li.
Exactly. So if we look here, we'll have the equation where we have an invisibility of 1.2, and we have also another invisibility in the labor equilibrium, and then no other invisibility is found, which is fine. Okay, let's now proceed to the analysis of the results, and I want to show you a technique that I in general prefer to do in order to analyze the results. So we'll see that we have an Excel sheet that is extracted. Okay, I will show you. I will share it now. So now I'm sharing the Excel sheet with the results. You can see it, right? So those are the values, the table that we get with the results. And in general, given the fact that later when you will work with real models, it's important to make sure that I understand every single number that I obtain and that I analyze everything. So in general, I mean, it's a personal preference, but then I'm open to any other suggestion. What I prefer to do is to highlight the variable that I manage to analyze. So the initial shock was an increase in capital in labor supply by 20%. So I will highlight this variable. The increase in labor supply, as we agreed, will lead to, Aziz, what do you think?
An increase in income?
No, before.
Before.
Increase in wages.
Reduction in
wages, exactly, because labor supply increases. So that's why wages will decrease by 4.4%. When wages decreases, this means that labor demand is going to increase. And labor demand now, we have a very important thing that we have to take into consideration is the sector intensity of the two, is the factor intensity of the two sectors. Okay. What does this mean? In order to understand how the two sectors will react, we have to calculate the capital to labor ratio of each sector. And before we continue the analysis of the results, I want to calculate the capital to labor ratio of agriculture and industry. So the capital to labor ratio of agriculture is equal to 1/3, which means that the capital to labor ratio of agriculture is 0.3, while the one of industry is equal to 3
divided by 3,
which means here that, relatively speaking, industry is more capital intensive than agriculture. And this is very important in order to understand how my two sectors will react. And whenever we have that's, I mean, very important. Whenever you work with a real SAM, there are several statistics that you have to calculate in order to understand the different characteristics of your economy. What does this mean? in general, whenever I start working with any matrix, the first thing I do is calculate 5 main indices. The first index is to calculate the capital to labor ratio of each sector, because this will help me understand how each sector will react when we have a certain shock, okay? And understanding the capital to labor ratio is very important in general for the economy, and especially when we're going to analyze a CGE model. The second important index that we have to calculate is how the domestic supply is allocated, meaning that what is the percentage consumed by urban and rural households? What is the percentage consumed by the government? What is the percentage that goes to exports? And what is the percentage that goes to the investment? Because this will help me understand how total demand, what is the structure of total demand I have in the economy. That's the second thing. The third thing that we have to calculate from the social accounting matrix is an export performance index. And the export performance index is measured by the share of exports to the production of the sector, in order to see to what extent the sector will provide part of its production to the domestic market, and the rest will be oriented or directed to the rest of the world. That's the third statistic. The fourth statistic that we is measured by, can you hear me?
Dr. Shaheen, your voice was breaking. You said the fourth.
Okay, so did you hear the part?
We heard the third. We heard the third export performance.
Okay,
but fourth, your voice was breaking.
The fourth is import penetration, or the penetration rate. And the penetration rate is measured by imports over production minus exports plus imports. What does this statistic mean? It means to what extent my total demand is partially, you can hear me well?
Yes, yes.
Okay, so to what extent my domestic absorption is satisfied by imports, and that's what we call the penetration rate, because at the end it will be imports over Y minus exports, because exports are not directed to the domestic market, plus imports, and that's the penetration rate. Okay. Another interesting, I would say, index that we can calculate as well, what is the share of each type of tax receipts in the government revenues, meaning that to what extent tariff revenues represent an important share of the government receipts, or to what extent income taxes, they represent an important share of government receipts, because this will help me understand if, for instance, I reduce tariffs, I'm having a trade liberalization simulation, or I'm imposing a new tax, like a tax value, a VAT, for instance. So this will, all these descriptive statistics of the social accounting matrix will help me have a better and a more sound analysis of the results. Okay? Any question on this before we continue?
Will be calculated from this Excel sheet, يعني from an Excel sheet, or from the SAM itself?
Sorry?
يعني the values, or from the SAM before starting?
From the SAM. We do this from the SAM. That's the first thing that we do before we start working on a CGE model. we do all these descriptive statistics on the SAM in order to understand very well the structure and the content of the SAM, okay? And then whenever we're going to run a CGE model, we'll be very familiar with the structure of the economy, so we'll be able to analyze the different values that we get from the SAM, from the simulation, sorry.
So we use the sum just for the analysis of economic, not
exactly, because that's the SAM that we will be including in the code itself. So before I run the GUMS code, I have to calculate. The more indices I calculate, the better, because I will be understanding all the interrelations between the different agents and the different sectors in the economy, and then I run the code.
Okay.
Another important thing that we have to analyze also in the SAM is the input-output table. Because we have in the input-output table the backward and forward linkages between different sectors. And the backward and forward linkages are very important to analyze in order to understand how a certain shock will have an indirect effect on different sectors. What does this mean? It means that, for instance, if I reduce oil subsidies, so the decrease in oil subsidies will affect the demand for oil. And this means that all energy intensive industries will be more affected than energy less intensive industries. And moreover, we can also, through this, determine to what extent my domestic economy is integrated or not. Because if I have a lot of zero flows in the input-output table, this means that I don't have a lot of backward and forward linkages in the social accounting matrix. Okay, is that clear? Great, so we can move with the analysis of the results. So I remind you that the initial shock that we had, an increase in labor supply that led to an increase in labor supply by 20%, which led to a decrease in wages by 4%. The decrease in wages will lead to an increase proportionally in the labor demand by 20%, because we must have a total demand that is equal to the total supply. Okay. Once we have this in mind, given that labor demand increases, I will be able to produce more. So if I want to produce more, I need capital as well. But given the fact that capital supply is constant by assumption, this means that capital demand will also remain constant. And that's why here the variation of capital demand for agriculture and industry is equal to 0. But the rent has to increase, because it's the rent that will do the adjustment. So if I have an increasing rent, a decreasing wage, an increasing labor supply, and a constant capital supply, my income will increase by 14.6%.
But also prices will increase. Prices as well.
Yes. And now we have to come to the part where we have all the sectoral variations. Okay. So one of our assumptions, so now we have two things that we have to bear in mind. The first thing is that the price of agriculture is the numeraire, right? So it's constant, and that's why we have it here constant. And the second thing, that industry is more capital intensive than agriculture, correct? Because this capital to labor ratio is 1, and for agriculture is 0.3, okay? So let's move to the changes at the sectoral dimension. So one of the intuitive things that we have is consumption of agriculture. So consumption of agriculture, it's totally normal that it will increase proportionally to the production, because, proportionally to income, because price is constant. So that's why the consumption of agriculture increases by 14.6%, which is proportional to the increase in our income that we have here. And by definition as well, the increase in consumption of agriculture must be equal to the increase in consumption of, in the production of agriculture. That's why we have here also the same number. The
In
final
order
thing that we
to
have to
an
analyze,
equilibrium.
sorry?
I said that the consumption and the production of agriculture are the evolution of them are the same, because at the end we will have our new equilibrium.
Exactly. And the last thing that we have to do now is to understand two things. To understand why the price of industry increased by 4.6%, that's one. And two, why consumption of industry and consequently its production, or the inverse, increased by 9.5%. So if you have an idea, go ahead. Maisa, what do you think? Any ideas, Maisa?
No.
Mahmoud, any ideas? Mahmoud? Any insights on why we have this? The question why the price of industry increased and why its consumption increased less than agriculture. Shayma, Wahba, any ideas?
No. No.
Rania?
I see that the capital divided by the labor of agriculture is minus than 1. I think because this ratio, but how to explain, I don't know. I think the ratio capital divided by labor is the main reason. But I don't.
Yes, it's the main reason, but
Cost of
how we can
production?
explain this mechanism?
Can I guess the answer? Is it because of the form of the production function, and that we're having perfect mobility of labor and capital? So
how?
So since we're having perfect mobility, so we will move the factors of production to the sector where the price is higher.
But I imagine that I mean, if we follow this analysis, so in general, the initial shock was an increase in labor supply, and the increase in labor supply led to a decrease in wages. So this means that workers will move from the agriculture sector to the industrial sector, right?
Yes, exactly.
Because in theory, wage is higher in the industrial sector.
Yes.
Yes. Yes.
But we'll have this mobility until we have just one level.
Until we're having, yes, the same level.
Exactly. But in this case, if labor supply increases, so this means that I'm able to produce more of the agriculture good, right? Agriculture is relatively more intensive in labor.
Yes.
So relatively speaking, this means that the industrial good is becoming more scarce than the agricultural good.
Yes.
And that's why its price is going to increase. And if its prices increase, this means that I will now have two effects that will shape the structure of my consumption in terms of the industrial product. I'm having an income effect and a price effect. My income increases by 14.6%, which should lead to an increase in the consumption of industrial goods. But at the same time, its price increases by 4.6%. So it should reduce its consumption. And that's why in net terms, I'll be consuming more of the industrial good, but relatively speaking, it's less than the agricultural good in terms of increase. And proportionally, the production will be also equal to the consumption, and clearly in the same line of what I was presenting, my production of industry will be less than the production of agriculture, because the initial shock was a higher increase in labor. And bearing in mind that agriculture is more labor intensive than industry, so this means that agriculture will benefit more from the increase in labor than the industrial sector.
Because at the end, in what comes to the industrial sector, it's this fight between the quality effect and the quantity effect.
No, but we're not modeling this.
Okay, I see.
And actually, Aziz raised a very important issue, that never ever in your analysis, when you analyze a CGE model, start to assume things that you do not model. Because we have to stick to two things: to the data that we have and to the equations that we have. Beyond this, it will not be really withdrawn from the CGE model. Okay? So we have really to stick to the data that we have and to the equations that we have. Perhaps I can use other sources to have some further potential explanations, but I have really to make the data speak, not to have some assumptions on things that I do not explicitly model in my system. Okay? Any questions on the results and on the way we analyze the results? Okay, so if you don't have more equations on this, I will send you the results of the Excel sheet and the code. Okay, so Ramaj I will send them to Ramaj right away, and she will send them to you, and then we will build our new model with the government and with the rest of the world with the code I will send you. Okay?
Okay.
Doctor, can I ask about a sign, a dollar sign?
Yes.
In GANs. Yani when I'm talking about in calibration and the equation is written as a parameter like beta, dollar sign, a certain variable. What does it mean?
The dollar help me in general impose a condition.
Okay.
And that's why we can use it to put a certain constraint on a certain variable, meaning that perhaps I will run this code for some sectors and not for the other sectors, and so on.
Okay, thank you.
Just a second, I'm sending to Ramaj the file. So you will receive two files, the code and the results. So now you have you have received until now 3 files, the basic model that I sent you, the simple model, and the results of the simple model. Okay? You received it? Okay, until you receive it, I will share with you the new code, sorry, the new model structure, okay? Because now we'll move to the next model where we have a more realistic model that is the one of the government and the rest of the world, okay? So okay, so now we have the new model that we'll call open economy and government. So we assume that we have a Cobb-Douglas production function, an economy with the government, two factors of production, two goods, perfect mobility of labor and capital between sectors. That's why we have one rent and one wage. No savings. We have an equilibrium for the labor market, capital market, and goods market. We have a government, and we'll have to introduce a trade balance, okay? From your perspective, if we introduce the government, this means that what kind of flows will be modeled?
Its consumption, for example.
Government consumption, what else?
Taxes.
Direct and
Taxes,
indirect
exactly. Tariffs, exactly.
Expenses.
Subsidies.
Sorry?
Expenses.
Expenses.
Government expenses.
Consumption.
Government consumption, which is part of the government expense.
Subsidies.
Sorry?
Subsidies.
Subsidies, exactly. But we'll make it a bit simple, given the fact that we're still working with some fictitious model. And if we introduce the rest of the world, so the two basic flows that we will have are evidently exports and imports. Okay? So in general, in this session, when we have, I mean, an in-class and a physical session, not a virtual one, I have a long derivation that I always prefer to do on the board to show you the main idea behind the constant elasticity of substitution and the constant elasticity of transformation. But it will be time consuming and not very convenient to do it here on Zoom. So what I will do, I will send you this detailed derivation by email so you can understand the rationale behind the trade equations. Why is that important? Because as we will see in like 95% of the CGE models, we model the import equation and the export equation through what we call a constant elasticity of transformation and a constant elasticity of substitution. Okay? The main idea of the constant elasticity of substitution and the constant elasticity of transformation is that domestic products and exportable products, exportable, not exported, meaning that domestic products that are likely to be exported are not identical, and that there is some imperfect substitutability between them. Because perhaps I have to, as I said on the first day, I have perhaps to translate the labels, I have to change the packaging, and all this will make the domestic product not identical to the exportable product. Okay, that's one. And two, when I will import different products, they are not identical to the domestic products. And that's why, given these differences between them, I have to take this into consideration. We take this into consideration through a functional form called the constant elasticity of substitution for imports and the constant elasticity of transformation for exports. The mathematical formula of both equations is identical, but the economic interpretation is different, because for one, I'm talking about the substitutability of what I'm producing domestically and what is produced in the rest of the world, which is imports, from the demand perspective, okay? Because whether consumers will consume domestic products or imports. So that's why it's a constant elasticity of substitution from the demand perspective, okay? And we have also a constant elasticity of transformation function from the supply perspective. Am I going to supply my products domestically, or I will send them to the rest of the world? So that's why the CET, the constant elasticity of transformation, compares the domestic production, whether it will go to the domestic market or it will go to the rest of the world. And the constant elasticity of substitution will compare between my demand, total demand, whether it will be satisfied by imports or domestic products, okay? So that's the main idea. We'll see that we'll have some equations that will not change from, with respect to what we have seen in the previous models, and some equations that are new. So the first part here, we have y that is equal to AK alpha L1 minus alpha. Nothing has changed, and clearly we must have the index I because we have two sectors. Then we have, here I'm just changing, instead of having W and R, but it's more or less the same. I can keep them as W and R. I have the price of labor, which is identical. I have the price of capital, which is identical. And then I have now the revenue. And here I'm assuming that I have a representative agent, and this representative agent will earn the income of both private households and the government, meaning that implicitly I'm including the government in this agent. I can have a separate equation and call and distinguish between rev private and rev gov. For rev private, I will have the revenue of labor and capital, and rev gov, I will have customs and taxes. But to make it simple, I'm assuming that I have a representative agent who will earn the total revenue, and this total revenue will be allocated on all the goods. And that's why I will have one consumption function in the next line.
So
okay?
So Professor, it's like the revenue of the whole nation, of the whole economy.
Exactly. So it's the national income, more or less.
Okay. More or less, yeah.
And then we have my domestic production will be equal to what is being supplied in the domestic market and what will be exported. Okay. Then we have the equilibrium of supply, of labor supply with labor demand, the equilibrium of capital supply with capital demand. And then we move to the part where we have a bit, some complications. And that's why I told you that there is a derivation we can use in order to prove this. I will just explain the rationale behind and then send you the detailed derivation because of time constraint. So what does the first equation mean? Here we have D that stands for the domestic demand. AD is a scale parameter. C is the total consumption. PC is the price of consumption. And P is the price of producer. And then we have sigma, that is the elasticity of substitution. So economically speaking, what does this function mean? it means that the higher the domestic prices, okay, the lower the demand, because we have here the price in the denominator. That's here there is a sub-index called D that is missing, okay, because that's the price of the demand. And I will come back later to the definition of this, okay? So we have here the price, in the higher the price, the lower the demand. But I have here a ratio that is PC over PD. And here it's relative price. A relative price of what? In general, I have a price called the price of consumption, because at the end, my consumption basket will be composed of two goods. Will be composed of a domestic good called D and an imported good called M. And we have a price for the domestic good and we have a price for the imported good. So this means that at the end, I will have a price of consumption that is a weighted average of the two prices. Why it's a weighted average? Because I will weight each price with the share of this good in my total consumption. In other words, what I have here, so as you can see here in this equation, PC multiplied by C is equal to PD multiplied by D plus PMI multiplied by M. PD represents the price of the domestic goods, and the price of the domestic goods is simply the price of producer multiplied by the tax that we pay, right?
Yes.
So that's the price of the domestic goods. And then the price of imports will be equal to the world prices that we have augmented by the tariffs, okay? So at the end, I will have two prices here. I will have the PD and the PM, right? This means that the price of consumption, PC, if I want to calculate it, it includes two goods. Sorry, it includes two prices. It includes, because my basket of goods includes both domestic goods and imported goods. So the price of domestic goods is equal to PD, and the price of import goods is equal to PM. But I want this weighted price index to better reflect the weight of each good. So that's why the weight of the domestic goods will be equal to D divided by C, and the price of the weight of imported goods will be equal to M over C. So that's why at the end I can say that PC multiplied by C is equal to PD multiplied by D plus PM multiplied by M. And that's the price of total consumption that includes both imported and domestic products. And that's the idea of this relative price, okay? C is total consumption, and clearly the larger my consumption, the larger I will consume from both the domestic good and the imported good. And for the imports demand function, here I have the larger the price, the lower the imports, which makes sense as well. And then here we have a scale parameter. It's a parameter that we'll have to calibrate, and we have the elasticity of substitution, okay? For the elasticity of substitution, in general, it's very simple to calibrate the parameter AD and AM, because AD and AM will be simply calculated by dividing D. I can say that AD, right, is equal to D
over C
over all this, right? And with this, I will calculate the value of AD. But what is more complicated here is the calibration of sigma, which is the elasticity of substitution. Because in theory, I have two unknowns and I just have one equation, and I will not be able to calibrate the sigma from my model. So that's why in this case, the sigma will have to be imposed either from the literature, or if I want to estimate it econometrically from another study. Okay? Moving forward, the import demand function is the same. Here we have the price of domestic goods, and I said it's the price of producer augmented with taxes. Then the price of consumption, which is equal to the price, the weighted price of both goods, I mean. And then we have the price of, yes.
Sorry for the interruption. Why we're adding a subscript I for the PCI and PDI and PM?
Because for each sector, I have an imported good and domestic good.
Okay. Thank you. I was confused. What is I?
No, it's the sector.
It's the sector.
Industry.
Oh, okay. Thank you.
And then we have the world prices of imports, as you can see here. And then we have one final equation that we call the export demand equation. Because for the export demand equation, in some cases, export demand equations can be subject to export tariff. In some countries, I mean, before joining the WTO, some countries used to impose a tariff on exports, okay? So that's why it will have a different effect in this case, because we'll have it in the denominator, not in the numerator. We have also an elasticity of transformation in this case, which is sigma x, okay? So here the tariff on exports is measured by DDX, and it will depend also on a scale parameter that is measured by gamma, and a relative price. So because exports are mainly produced domestically, so their competitiveness will be depending on the domestic price, but not of consumption, the domestic price of production, the producer price, which is PI, okay? So in other words, from an economic perspective, the ratio PM world with respect to PI, what does it represent? How we call this in economics?
La compétitivité du pays, en quelque sorte.
C'est lié à la compétitivité, mais c'est pas vraiment la compétitivité. What other... there is a concept. I mean, it's a straightforward concept.
Is it PPA?
No.
No.
Is it the exchange rate?
No.
So the price.
What else?
Is it the state of the commercial balance?
No, the trade balance is the last one.
Yes.
That we have here.
Mm-hmm. And it's in equilibrium.
Yes.
Normally.
What else? What does this?
Maybe.
Yes, go ahead.
Maybe it shows if the country is price taker or not, if it's a big or small country.
No, here we assume that it's a small open economy, and that's why we have a world price.
Okay.
How we call this economically? Here I have in the numerator the price of imports, and in the denominator the price of what?
The reference price.
The
reference price.
No, I mean that's the producer price in the denominator.
Mm-hmm. Yes.
And we said that the price of producers will be applied to the price of exports, right?
Yes.
So how do we call the ratio between the price of exports and the price of imports? Terms of trade?
Exchange? Non.
Comment?
Taux de change, non?
Les termes de l'échange, pas le taux de change.
Le terme de change, oui.
Non, les termes de l'échange, pas de change.
Ah, d'accord, oui.
Les termes de l'échange. So the terms of trade in English, okay? So it's more or less a measure of the terms of trade. Why? Because the terms of trade show the ratio between the price of exports and the price of imports, which more, it's straightforward terms of trade, but it's more or less a measure of the terms of trade. Okay. And then the final equation shows the trade balance, and we assume here that the value of exports is equal to the value of imports, because our trade balance must be in equilibrium. Okay, with this, we have seen how the model changes if we introduce new flows associated to both the government and the rest of the world. So what we'll do now, we will start coding this. Okay, now it's becoming really more complicated because we'll have several parameters to calibrate. We'll have several variables to add. So what I will ask you to do, perhaps before we do this, I suggest that we start with the break now, and then we start working on the code directly, in order, instead of having a break, instead of starting to work on the code and then we have the break. So we'll have the break now for 10 minutes, okay?
Okay.
10, 12 minutes.
Okay.
So we'll resume at 5:30, and then from 5:30 to 7, we will take an hour or so in order to work on the code itself. And then the last 30 minutes, I will introduce the dynamics and the rest of what we want to have, okay? So what you will do now, you will save the simple model I sent you as, we'll call it open, okay? Because that's the open model. And once we resume after the break, you will start coding. You will follow exactly the same steps. So we'll add the variables, we will add the parameters, we will add the new equations, we will add the mathematical value of the equations, the initialization, and we run. Okay?
Okay.
So have a nice break, and we resume in 12 minutes. all, let's start. Well, so now what we'll do, we will start coding this code in, as I said, in your own code. So what I will do, I will put the two slides of the code together so that you can see the whole system in one slide. So here is it. Now you can follow the same steps that we did. So now it's 5:35. You will have 15 minutes, okay, to write, to update the list of variables, the list of parameters, equation names, and if you have any problem, please tell me in the chat box. Any questions? I remind you that you can keep the same wage and rent that you already had. No need to change the names. don't know how. Does the tax rate depend on the product? So let's start to have a look at the different codes. Do you need more time? It's fine. What do you think?
I think we need more time.
Okay, so let's have 5 more minutes.
Okay, thank you.
Dr. Shahir, could you please
Yes.
share again the equation?
Okay. So how is it going? Still need more time? Shall we start?
Dr. Shahir, shall we insert
Yes.
another set for the domestic and the imported products, or for the...
Yes, I will send you the data later, but what we want to finish now, we will not run it anyway. I just want you to get a sense of how we can incorporate the new variables, the new parameters, and the new initialization.
No, I am asking about putting writing sets in the beginning. Would we...
No. We have the same set.
Oh, okay. Thank you.
Okay, I suggest we start because it's 6:10. So we will discuss, I mean, what you've done, even if you haven't managed to finish all the code. So who didn't share today anything with us?
Yes, me. Yes, me.
Okay, please go ahead. I will stop sharing my screen. Go ahead, please.
Okay. Just a minute. Share screen. Just a minute, please. Did you see or?
Yes.
Okay.
So please scroll up. We start from the beginning. So the set, it's fine. Let's move to the variables. Leon, income, consumption, production, capital demand, labor demand, wage, capital rent, price level.
Is it okay?
We don't
anything
have
missing,
the tax.
anything missing here? What do you think?
The taxes, TX.
Taxes. Is it a variable?
I
Sorry?
declare in parameters.
Parameter.
It's more of a
Exactly.
parameter.
Okay.
Yes, because it will be multiplied by the price.
What?
So wage, capital, rent, labor supply, price level, demand for domestic products. Anything missing here?
Exports and imports.
Are there X and M?
Yes.
It should be in function of I.
Sorry?
It should be in function of I. The exports and imports should be
Yeah,
in function
actually,
of sectors.
it's better to, I mean, we can skip the declaration here, but it's better to have it. I mean, which variables will be indexed over I and which variables will not be indexed over I. But adding to this, what other variables are missing? There are at least one variable that is missing here.
Leon.
Leon is the first one.
I guess.
Okay.
What else?
Sorry,
Shayma, please maximize your screen.
I guess the national revenue is missing.
It's the income.
Yeah.
What
yeah.
else?
Okay. Sorry.
So it's the world price of imports, because here we have, oh yeah, no, you have it PW, so it's fine. I didn't see PW because I'm used to PMW to this thing, because in general we have we can have the world prices of imports and the world prices of exports. So that's why in general it's better to have PMW. Okay. Anything else missing? Okay, let's move to the parameters. A, alpha, beta, sigma, sigma X, AD, AM. So AD and AM, we call them the scale parameter of the demand and scale parameter of imports.
Okay. Scale parameters of demand. And the scale parameters of import.
Yes. And then the gamma, it's the scale parameter of exports.
And alpha and beta, they depend on I, right?
Yes, that's the same comment we did, I mean, in the beginning.
Okay.
Okay, tariff on exports, imports, income, COYO, capital demand, wage, rent. Okay, let's move to the next part with the equations. Supply, labor demand, capital demand, income, demand for domestic goods, demand for imports, price of domestic goods, price of consumption, price of imports, exports demand, demand function, capital equilibrium, level equilibrium, goods equilibrium, trade balance. Okay, let's move to the mathematical notation. Yes. So yi, this one hasn't changed. Anything on the first equation? Ridvan, what do you think? Anything on the first equation?
Started modification from the demand, domestic demand. I keep the all supply, demand, capital demand, labor demand, income the same.
Yeah, what's the problem here now? What do you think?
It's the income. the income, we should add the taxes and the customs.
That's one, but before this, here we have a syntax error. Yes, exactly. You have to adopt the same notation, so it must be WL and WK everywhere. If you will change this, and this holds for both labor demand, capital demand, and income.
I think that I should add customs and taxes or not?
Yes, but before this, in the labor demand and capital demand, you still have W and R.
Okay.
Okay. I mean, if you have any of these errors, you can correct them while we're working on Shaima's code. Then you have to add taxes and anything associated to the government revenues. Okay.
We'll write taxes?
Sorry?
Plus taxes? Okay.
Yes, but this means that they have to be calibrated somewhere, because until now they are not really calibrated. But let's continue the rest of the model and come back to this later. So here we have the domestic demand, imports. Here for the demand for imports, you have to remove the space before the two dots and have a space after the two dots. Okay, consumption, price, okay, PD. Okay, PC is equal PPD.
Sorry.
Yes. In principle, it's fine, but yes, it's fine. Okay. Well, any comment on this? Clearly, if we run the model now, it will not work because first, we don't have enough data in in your code, because you have just the data for the simple model. And second, we didn't do the calibration. But let's, regardless the data story, let's move to the calibration and see what has to change. So first RO, it's not RO, it's WKO. Then WLO. Prices will change the data later. Capital, okay. Alpha, that's fine. AI. Oh, so you haven't added the new parameters.
I didn't add anything to the calibration.
Oh, okay.
Stop that equation.
Okay, so please stop sharing your screen. Thank you. Okay. Now, perhaps given that it's already 6:18, I will show you my code and show you some, you will receive it anyway, but I want to show you some particular things on the code itself. So now please check the code I will be sharing. So the sets, nothing has changed. I just updated the third model with that it's an open economy model without the government. Then we have the list of variables, to which we added the new variables I was talking about. And in general, another cosmetic comment, it will change anything, but in general, by convention, when we work on GUMS, in general, we have the variables in capital and the parameters in small letters, just to distinguish between them when we will be working with real models, okay? Then the parameters here, we have all of them. With all the new parameters, the Armington coefficient for imported goods, the Armington coefficient for local goods, that was the scale parameter I was talking about. Then the elasticity of substitution, the elasticity of demand, the scale parameter of exports, and so on. Then we have the equations, okay? That's the same list of equations you have. So the supply function, nothing has changed. The labor demand, nothing has changed. Capital demand, nothing has changed. And as you can see here, now the government, the national income is equal to the labor remuneration, capital remuneration, and the sum over I, because in order to calculate the taxes, here I introduced the formula of the tariffs and taxes. So the tariffs are represented by the DD, which is the tariff rate itself. Okay. And we have to multiply it by the value of imports, and the value of imports is equal to imports multiplied by the world prices of imports. Then we add to this the value of taxes. So the first term is the tariff and the second term is the taxes. And taxes are simply the tax rate multiplied by the price multiplied by the demand. I mean the domestic production. Okay, and all this is equal to the total income. Then in the next equation, demand is similar. So we have here, with the only difference is that now income here does not represent only the income of households, but also the government. Then we have the DI and the MI as they were noted. Then the PCI multiplied by CI, which is a weighted average of the two other prices. Then the price of imports, the exports demand, as it was presented. Then the equilibrium, here the equilibrium will change a bit because here I have now total production is equal to DI plus XI, because now my production will not be only consumed in the domestic market, but will be also exported to the rest of the world. Then capital supply, labor supply, trade balance, nothing has changed. And finally, the domestic prices that include domestic taxes. Okay. For the calibration, we will calibrate all prices again. We will assume that all prices are equal to 1. Here we have the data that should come from the social accounting metrics. And if you notice, now we have more variables because we introduced the rest of the world. So this means that we need labor, capital, exports, and imports. Then, as I said, we impose the value of the elasticity of substitutions. Here we assume that they are equal 5 and 3, and they don't change by sector. We can assume that they change by sector, but now we say that they are the same. Then that's the tariff imposed on agriculture and on industry. The wage remuneration, the capital remuneration. Then we will, a very important thing here in this calibration part, as you can see, for the imports, we want to transform it into from a value into a quantity. And here we do not divide by the price of imports because the price of imports includes tariffs. And here we want the value of, the volume of imports if we divide this by the price of imports, this means that I will obtain a lower quantity because I will have a higher denominator, right? That includes the price of the tariffs, I mean. So that's why we include here in the denominator the price of the world price of imports that do not include any tariffs. Then capital demand and labor demand, it's the same. Here what I'm saying in this equation is that, but this one, I mean, we can skip because in most of the cases we have it as a rate. Here I'm saying that my customs duties, okay, are equal to, the rate that is imposed, DDI, is equal to the customs duties divided by the total value of imports, which is more or less, I mean, another way to calculate the rate. But in general, we impose the value of these rates. Then labor supply, capital supply, nothing has changed. Here, we assume that the tax, that the indirect tax is 0.4%. Then we calibrate PM and PD as a function of what we had in the beginning. Then total production is equal to total value added as what we have seen before. Exports, we have to convert it from a value into a volume, and that's why we divided by PO. Then DO, we calibrated as YO minus XO. And here, what does DO represent in this case?
It is in blue, so...
No. I mean it's in blue, but it's the demand. But what? How I calibrate it here?
It's the demand at the base year.
At the base year, yes, but here it represents what is being supplied in the domestic market. Because I'm saying that DO is equal to YO minus XO. If XO represents exports and YO represents total production, so this means that
domestic
DO
goods
represents what I will supply on the domestic market. Another thing here, DO and XO are in volume or in value?
In volume?
XO in volume.
XO in volume because I converted into a volume. YO is in volume because I calculated as a function of K.
DO will be in volume.
That are in volume, as you can see here, because we deflated them by their prices. And then I calculate DO as the difference between YO and XO. So this means that DO is a volume as well. Then I calibrate the income, and I used my initial formula in order to calibrate it. And that's why, as we said in the beginning, the order is very important. So that's why all the previous variables have to be already declared, which is the case here. Okay. Then we have the consumption that will be calibrated as a function of its equation that we identified in the beginning. Alpha, it's the same. AI, it's the same. Nothing has changed. Beta I is the same. And those are the three new parameters that we calibrate. So here, these three parameters I calibrate as a function of, as you can see, two things, the formula and the sigma. So the formula I will take from the equations I noted above, and the sigma is imposed by definition. Okay? Any questions on the calibration? Anything that you don't understand before we proceed? Any questions? Anything that's not clear? How do you feel? You feel that you'll be able to do this? You'll not be able to do this? Anything that didn't cross your mind while doing the calibration? What is the most striking thing that you see here compared to what you are expecting before you're writing the code, before you started writing the code?
The tax rate on the product I, is it expressed in percentage or?
Here, yes, we divide by 100 because it's a rate.
Yeah. So is it 40%, 4%?
Yes. Yeah. But I mean, this value we can change.
Yeah, but here it is 40%, right?
Yes, exactly.
Okay, thank you. Thanks.
Dear Professor, I would like to ask a question, please.
Sure.
I would like to ask a question. Where is the subsidies?
No, here we don't have subsidies. And so because if we introduce subsidies, this means that we have to introduce the government as an independent agent that has some expenses and that has a revenue. Here I'm assuming that all the government revenues will be collected by my representative agent, and this representative agent will spend its income on consumption. So I'm not including any government expenses.
Okay, thank you.
Other questions? Okay, we can move to the initialization. So the initialization will be very straightforward, nothing exceptional. But now, as you will see, by definition, given the fact that we have now the rest of the world, so my numeraire will be the world prices. Why? Because if we assume that we have a small open economy, this means that it will be a price taker. And if it's a price taker, then it will it will make sense that all the prices are exogenous. Okay, so that's why we must have here the PWM, which is the import world prices, as an exogenous variable. Then we continue with the same model, open all using CNS, and then we have the parameters. I will just deactivate it for now in order to see whether my model is working or not. and then I will run a first simulation. Okay, so I will run the model, and as you can see, what I obtain here, I obtain an infeasibility of 4.4 multiplied by 10 to the power negative 16, which is correct. In the pre-triangular and post-triangular, I have a feasible solution to a square system, so that's good. I can close this and move to the listing, check if I have any infeasibility. I always do this even if I'm sure, but just to double check that I don't have anything that's great here. Because in general, when you will be working with real data, you will see that for your right-hand side and your left-hand side that you have here, when they calculate, I mean, see here, in general, your left-hand side and your right-hand side are exactly equal to 0. Sometimes they are equal to 3 multiplied by 10 to the power negative 16, because we'll be working with real data. So the same, comment holds in this case, okay? So we have here all the equations that are resolved. I can go through them to see what happened, okay? Then we can see the model statistics that we have here. So as you can see, we have a single equations 26. We have 26 equations with 26 endogenous variables, and we have single variables 30. This means that there are 4 exogenous variables, and here we have the 4 exogenous variables are labor supply, capital supply, and the world prices of agriculture and industry, which make them 4. And then this means that we can run now the simulation. Any question on this before I run the simulation? Okay, so now we will run a simulation. And the simulation will be, as you can see, the model is much richer. Why? Because we can have dozens of things that we can simulate. So at first I can simulate a shock in labor supply and capital supply. So a migration in terms of the labor market, or an increase in FDI, for instance. That's the 2 first shocks. I can shock also the world prices, and this can be represented, for instance, through a shock in terms of the oil prices that increase or that decrease, or an increase in world agricultural prices, because we know that in economics, we can generally assume that agricultural products are more subject to perfect competition rather than industrial projects that are subject to imperfect competition. So we can assume that world prices are can change for agricultural products. We can also have some shocks either for tariffs or for taxes. I remove tariffs, I impose a higher tax, I impose a lower tax, and I can also simulate a combination of different simulations, okay? Because that's what we do in reality. I mean, whenever, for instance, the Prime Minister will ask me to run some simulations on the IMF program, for instance. So in this case, I will first simulate the effect of removing subsidies, then the effect of imposing a value-added tax, a third shock if I have a tariff, and then I can run a shock when I combine different simulations together to see the net effect on the whole economy.
That's what we call policy mixing, right?
Exactly.
Yeah.
And for the policy mix, but I mean, in general, the policy mix that has been proposed by Tobin was more a policy mix on the interaction between monetary policy and fiscal policy, and the optimal dosage of both. But here we can accept the concept of policy mixing in the sense of simulating different policies. But the theoretical concept of policy mix is a bit different. Okay. So now let's assume that the shock that we'll have, that I will remove the custom duties on imports, okay? Before I do this, so this means that the shock I will simulate, as you can see, I will assume that my DDI is equal to 0. And by assuming that DZI is equal to 0 means that all taxes will be equal to 0. Okay? If I do this, what will be the direct effect of this shock on my economy?
The national revenue will decrease.
That's one. So custom in general, if we remove tariffs, so custom duties will decline or will be equal to 0 if I remove the tariffs. So this means that in my case here, the income will decrease. That's one. Two,
Imports will increase.
exactly, imports will increase because they will become more competitive from the consumer perspective. The demand, what happens, Mohammed, in the demand? It will increase, it will decrease. Okay, so and if actually if imports increase, this means that demand will increase. Exactly. What else? If demand will increase, this means that now we have to take into consideration a new dimension because our domestic producers will face some competition from the rest of the world.
So they have to reduce their prices.
Or they will have to reduce their production. And that's what we will see because the fiercer the competition, they might be that they might reduce their the production of the sectors that is more important. Okay, and this will clearly affect in this case if I will reduce my production of a certain good. So this will be reflected on the capital demand and labor demand. And from this will have a secondary effect on income, which will lead to an effect on consumption. So do you see the storyline that we try to have? This, I mean, this storyline, we have to write it in the report. And the worst report whenever you work on CGE modeling or a paper on CGE modeling is to have a very descriptive analysis of the results without really examining the economic relations and the mechanism that we have that will link different variables and different agents. And this is fundamental in the CGE analysis. So I will run this simulation where I assume that tariffs will be equal to 0. So see, I have here one error because I didn't remove the off text. So I will run it again. So as you can see in my pre-triangular iteration, I have an infeasibility 2.4, which makes sense because that's the infeasibility associated to tariffs. But then I have more iterations. Now remember, in the very first model, I just had 3 iterations. In the second model, I had 12 iterations. Now I have 25 iterations. In the real model, it can go up to 100 iterations. Okay? And then I have a feasible solution to a square system. I will go to my listing to check the infeasibility. So I have an infeasibility I have an infeasibility in the income. I have an infeasibility in the price of imports, which makes sense. I have an infeasibility in the import prices, and that's it. So whenever I have the parameter DD, I will have an infeasibility. So I can go back to my put file in order to see the results. Okay. And I will open it.
Dr. Shahid, if I'm talking about increasing the taxes, then in my model,
it by a positive coefficient.
Okay, يعني like مثلا imposing a tax of 10%, I will multiply it by 0.10.
يعني if my initial tax was 0.14, then I will multiply 0.4 by 1.1.
Okay.
Can you see my results or not?
No. We can still see the gums.
Oh, okay, sorry.
Yeah.
So now I will show you the results. And now it becomes more interesting because we have more things to analyze. So we'll start again with the initial shock that we have. What I have, the DD that, so the domestic, I mean the customs duties that will be equal to 0. And as we said, if I remove tariffs, the immediate effect will be an increase of imports. And that's what we have here. So imports of agriculture and imports of industry increase by 14 and 19% respectively. If imports, and sorry, before this, given the fact that my tariffs are removed, so the price of imports will decline, which will lead to an increase in imports, right? If the price of imports decline, and at the same time, we said that if we remove tariffs, the immediate effect, as was suggested by Aziz, income will also decline, right? If income declines, this means that I will consume less because my income decreased. But we have to compare the price effect induced by the decrease in the prices of imports and the decrease in income. But as we can see here, for the total consumption of both agriculture and industry, we can see that the consumption decreases. And if the consumption decreases, this means that the income effect is very important. And if we look at the, interestingly, PC, if you remember, represents the weighted average of the two prices, of the domestic price and the import price, right? Here, the price of consumption decreases. So in theory, I should have been consuming more.
More, yes.
But my consumption decreases because the income effect induced by the decrease in income when I remove tariffs exceeds the decrease in prices. So that's why my consumption will decrease. And if my consumption will decrease, this means that I will have to see what happens for the price of the domestic goods, because we can see here that the price of domestic goods decrease, right?
Yes.
And the price of domestic goods will decrease for which reason? What do you think? Why the price of the domestic goods will decrease? So PD, again, whenever we have any queries like this, we have to go back to the equation that we have.
It's not a competition effect, no?
No, it's not competition because I'm not modeling the number of producers.
Okay.
I mean, it's a competition through imports, yes.
Yes, this is what I meant.
Okay.
When the income decrease, so households will not have enough money to buy goods, and that's why maybe the price of these goods are decreasing.
So, I mean, the price of, as I said, I mean, the rationale is correct, but we have to justify it through the equations. So my PD is equal to taxes multiplied by the producer price. So if taxes are constant, this means that the effect will be due to the producer's price. So you have to check the producer's price, and the producer price here is declining as well. It's the P here. So P and PD are declining almost proportionally, right? Why, economically speaking, why shall the price of the producer decline? Because, as you said, the producer is facing a fiercer competition through more imports. So if I'm facing more competition from the imports, this means that I might have to reduce my domestic production. And if I reduce my domestic production because of this competition, and that's what we see here, that the domestic production of agriculture decreases, while the domestic production of industry increases, right?
So
This means
that
that I'm producing more of industry and producing less of agriculture. So if there is a heterogeneity between both, we have to go back to the structure of imports.
yes.
Because here the imports of industry increased by 19% and the imports of agriculture increased by 14%. So how we can make this compatible with the variation in the production? Bearing in mind that my production will be allocated between the domestic market and exports, right? So we have to look at exports, and that's the beauty of CGEs. As you can see, whenever we try to analyze a variable, we have to see the rest of the economy, what's going on. And what we see for exports here is that exports are extremely increasing in order to have the equilibrium with the increase in imports. So here we have agriculture that will be exported, more exported to the rest of the world than the industrial sector. So this means that at the end, agriculture, I will reduce my my total production, but more exports will go to the rest of the world at the expense of the domestic product. So I will sell less agriculture products on the domestic market, and I will sell more exports of goods to the rest of the world. Okay?
And that's all to keep the terms of trade kind of fixed.
You mean the trade balance?
Yes.
Yes, the trade balance, yes, exactly. And given this structure, we'll see that the domestic demand here of agriculture decreases and the domestic of industry will decrease as well, because we are producing less and because we are exporting more and because we are importing more. So I will supply less of products in the domestic market because I will send them to the rest of the world. I will consume less of the domestic products because I'm consuming more imports. And this, given the fact that the demand, I mean, I'm producing less, this means that the demand for capital and labor in general will, given the fact that I'm reducing my production of agriculture, so the demand for labor and the demand for capital will decline in agriculture, but they will increase for industry because of the fact that my labor supply and capital supply in general are constant. But since the decrease, here we can see that the capital demand in agriculture decreases and that the labor, the capital demand in industry increases, but less than proportionally. So that's why the price of capital will decrease, because the decrease induced by the decline in agriculture is higher than the increase induced by industry. And the same observation holds for wages, but through a different channel. Why? Because here we have the decline in the labor is negative 0.2, negative 2%, but the increase in labor is 11. And the net effect on the wage is negative 13. Why? Because of the same observation that agriculture is more intensive in labor. So the decline in the labor demand coming from the agriculture sector will make the total wage of the economy decline. And that's why my total consumption will decline. One, because of the decline in the receipts coming from tariffs. Two, because of the decline in wages. And three, because of the decline in rents. Okay? So that's the advantage of having a CGE model, because we can really examine what's happening at the macro level, what's happening at the sectoral level. And it's very important also, as I said, to have this storyline of results. Okay, any question? Anything that's not clear? Okay, in the last part that we'll do now, I will go briefly through the introduction to dynamic models, and in like 7 minutes, and then in 3 minutes I will show you a real model for the Egyptian economy. Okay, just to show you to what extent it's really in line with what we've been doing. So this is a very short and quick introduction to dynamic models. In general, we have two types of dynamic models. We have what we call, as I said in the beginning, we have for CGE models, we can classify them into single country and multinational models. And then we have static models and dynamic models. Static models are interesting if I want to compare before and after status. But for dynamic models, we have two types of dynamics. We have intertemporal dynamics and we have sequential dynamics. The sequential dynamics means that I have several static models that I'm linking, and I will link these different static models. Okay, what does this mean? It means that I need to find some variables that will link each period to the other. Okay, intertemporal models means that we will have a model that will take into consideration the intertemporal adjustment. Okay, so this means that in sequential models, I'm assuming that time is discrete, year 1, year 2, year 3, year 4, and so on. In intertemporal models, I assume that time is continuous, not discrete. Okay, whenever we want to simulate a dynamic model, there are three important things that we have to take into consideration. Okay, clearly, the first thing is that we will introduce a T index, because now we have a dynamic model. So all the variables will change by T, that's one. Two, we have to introduce the most important thing that characterizes any dynamic model, which is capital accumulation or investment. Because what I invest today, investment is a flow or a stock. What do you think? Investment is a stock or a flow?
It's a flow.
It's a
flow.
flow.
And the more the inflow increases, the more the stock of tomorrow's capital will increase. So that's why the first equation that we have to introduce here is the capital accumulation equation. And the capital accumulation equation is represented through this equation that you can see now, where my investment in sector, I mean, whether it's private or public, of sector G in year T, will be added to the stock of capital that I have, and I have to take out the depreciation rate. Okay, and after this, why is that important? Because in this case, the accumulation of investment will increase the stock of capital, and the stock of capital will affect the production, right?
Yes.
And that's why, given, if you remember from your undergrad courses in growth theories, we have the steady state of the economy. And the steady state of the economy is simply, or what we call the balanced growth path. So the balanced growth path is represented by the path where all my macroeconomic aggregates will increase with the same growth rate, which is the population growth rate. So that's the balanced growth path that was advanced by Solow in his model. And that's why we will have to develop what we call the business as usual. And for the business as usual that we do, what we'll do, we will predict the evolution of the economy, okay, where all my macroeconomic aggregates will evolve with the same growth rate, which is the population growth rate. And in this case, I can assume that my economy will increase by 2%, 1.8%. And in general, we use the IMF forecasts of the population growth. Then this means that I will imagine the development of the economy without any simulation, okay? So I will imagine the counterfactual, the evolution of the economy in 2015, for instance, okay? And then I will do a simulation. And for instance, I will remove subsidies and I will examine the effect of subsidies over time. And this will be my first simulation, simulation 1. So my interpretation will always be how my GDP, for instance, in year 2045 is different from my GDP in 2045 without a shock. And this is very important, meaning that all my interpretation will be with respect to the business as usual, okay? So I'm not examining in absolute terms, but I'm examining what will happen in 2014 with and without a shock. What will happen in 2013, in 2030, with and without shock, and so on, okay? So this means that I will have to assume that all my exogenous variables will increase with the same growth rate of the population in order to have this balanced growth rate, okay? And after this, my endogenous variables, they will be determined by the model because they will be indexed with an I, okay? So that's the really basic idea about dynamic models. Any questions on this? Anything that's not clear? So to conclude our training, I want just to highlight 4 things. So first, I mean, GAMS and CGE modeling are in general like Stata, like any software that you use, and it's a learning by doing process. So the more you will apply it, the more you will learn. And I mean, I constructed Egypt's model. It was a self-learning process, 100%. So you can really do it on your own with the introductory elements that you have, because if you don't do it on your own, even if you have dozens of trainings, you'll not be able really to master neither CGE modeling nor GAMS. So it's really a learning by doing process. There is an excellent book in CGE modeling that was done by Bernard de Caluet. That's like the Bible of CGE modeling. It's very well done. I will send you the reference in, you will see it in the program, and you will see it also in the references I have. It's really very pedagogical, and it adopts a step-by-step approach. So I highly recommend this book. And a complementary resource as well is the PEP network. And for the PEP network, you will see that there are several papers and several codes that are available that you can use and that you can tailor for your own economy. But I don't recommend using these models before you really master every single command that is written in these codes. Otherwise, it will become a drop-down menu, or a process where you will just click on a button to get some results, and you will not really become an economic modeler. So that's why these resources are very rich, are very helpful, but before using them, make sure that you understand every single command, okay? The third point is that you will receive a folder that includes 3 subfolders. A folder with the codes that we had, including the last code. A folder that includes the slides that we have seen during the 4 days. and a folder that includes some papers for a model I did for Egypt, a single country model and a multinational model, and some other helpful papers in CGE modeling, either with codes or without codes. And you will see also that there are some exercises for how we can construct a social accounting matrix and some instructions to do it whenever you want to construct your own social accounting matrix based on IFPRI's work. The last point, so you have my email. If you have any questions, don't hesitate. And you will also receive a link, and this is very important for us because that's the first time we do the CGE course online. In general, it's a 3 days training workshop that we do, I mean in class, not online. So please tell us constructively and frankly your feedback of the training workshop in order to improve our future trainings, especially that we're not really certain whether we'll be able to have any physical trainings with COVID-20 with the recent mutation of the virus. So, I mean, we really hope that the next training will be either in Cairo or another city, but otherwise we'll have to have all our trainings virtually. So please fill the survey that you will receive and give us, I mean, all the comments that you have, because this will be really, really important to us. Do you have any questions, any comment, anything that's not clear?
Thank you. Thank you, Doctor.
Okay. So with this, I will just ask you for two things. So first, we will need to have a group photo, because that's what we do in general at the end of the training. But given the fact that we're not physically present together, so we'll have a simple screenshot. So please turn on your cameras and smile, and we'll have the screenshot that I will share it with you later. I will send it to Ramaja and she will share it with you. And then if you have, I mean, any questions, comments, don't hesitate. So I'll take the photo now. Thank you. So it was really a pleasure to have you. It was very short, but I'm very happy to meet you virtually. Don't hesitate to get in touch if you have any questions. And last but not least, and it's the most important thing, I really want to thank Ramaj for her excellent work that she always does in any training, whether in making things very smooth in terms of the application process, the sending you material, sending you inputs. So it's really, I mean, I would like to thank her very much. And stay safe. Merry Christmas, and I hope we'll be able to meet very soon.
Very soon. Yeah.
Thank you.
Thank you very much.
Thank you,
Thank you very much, Professor.
Thank
Merci
you.
beaucoup. Merci beaucoup.